Welcome to the deep dive. Okay, let's jump right in. If you're running a SaaS company that's growing fast, you probably know this headache. Your analytics just can't seem to keep up. Right when you need answers, things slow down.
Yeah, absolutely. It's a classic growing pain. You're scaling users, features, everything. But getting the data insights about that growth, that starts lagging big time.
And that's often when Google BigQuery enters the conversation, with its promise of serverless scale. But what we found digging into this is that just like flipping a switch to BigQuery, that's not the magic bullet.
Not quite. It's powerful for sure. But the how matters, the architecture you build around it. That's what makes or breaks it for speed and efficiency, especially in SaaS.
Right. So our mission today is really to pull out those key architectural best practices. How do you actually use BigQuery effectively to scale your SaaS analytics?
Okay, let's break it down. BigQuery has some fundamental advantages for SaaS. First off, it's serverless. No servers to manage, patch, scale, that's huge.
Takes a whole layer of operational burden away.
Exactly. And then there's the separation of compute and storage. You can scale them independently.
Yeah.
Need more query power, spin it up. Need more storage, it handles it. Very flexible.
Plus that columnar storage thing, right? That's different from traditional databases.
Yeah, and really efficient for analytics. Instead of reading entire rows of data, it only scans the specific columns your query needs. Massive speed difference for typical analytical workloads.
So the foundation's strong, but getting data in, especially with SaaS platforms generating just floods of event data, real-time stuff, that feels like the first potential hurdle.
It absolutely is. Efficient ingestion is critical. You can't have a bottleneck right at the front door. The sources we looked at really emphasize using the BigQuery Storage Write API.
Okay, the storage rate API.
Yeah, think of it as like a high-throughput direct pipeline into BigQuery. Much better for streaming large volumes compared to older methods. Combining it with something like Dataflow for processing, that's how you handle high-volume real-time event streams without things backing up.
Got it. So data's flowing in smoothly. Now, once it's in BigQuery, how you organize it matters, doesn't it? For speed, but also for cost.
Hugely important. This is where partitioning and clustering come in. Seriously, don't skip this step.
Explain those a bit. Partitioning first.
Okay, partitioning is basically chopping up your big table into smaller, manageable chunks based on a specific column. For time series data, like SaaS events, partitioning by date, usually daily, is almost always the way to go.
So when I query for yesterday's data, BigQuery only looks in yesterday's partition.
Precisely. It doesn't have to scan the entire massive table. It immediately narrows down the search. Drastically cuts down the data scanned, which means faster queries and lower costs.
Okay, makes sense. And clustering.
Clustering then sorts the data within each partition based on one or more columns. So for SaaS, you might cluster by, say, userid or tenanted.
So if I partition by date and cluster by user, and I query for a specific user's activity yesterday?
BigQuery first goes to yesterday's partition, and then within that partition, it knows exactly where that user's data is likely located because it's clustered together. Even less data to scan. It's about minimizing the work BigQuery has to do.
Right, guiding it very precisely. Cool. Now, sauce data, it can get messy, right? Nested events, user properties, feature flags, lots of relationships. How does BigQuery handle that complexity without forcing us into, like, a million table joins?
That's another strength. BigQuery handles complex nested data types really well. Things like ARIs and struct-TTs.
So you can keep related information together in one row.
Often, yes. Instead of normalizing everything out into separate tables and then doing complex, extensive joins every time you query, you can represent a lot of that structure directly within the main event table. Fewer joins usually means faster queries. It simplifies the data model too.
Less complexity, faster answers. Okay, theme emerging here. But let's talk cost again. That on-demand pricing is flexible, but I've heard stories.
Yeah, you pay per query based on data scan. If you're not careful, or if you haven't optimized with partitioning and clustering, costs can ramp up unexpectedly. It's powerful, but you need governance.
So how do you keep tabs on it?
BigQuery provides tools. The information schema views are your friend here. They give you metadata about your jobs, your tables, how much data queries are scanning.
So you can see which queries are expensive.
Exactly. You can monitor spending, identify inefficient queries that maybe aren't using partitions properly, and optimize them. And as your usage pattern stabilizes, you might look at flat rate or capacity-based pricing for more predictability. But active monitoring, non-negotiable.
Okay, let's make this concrete. Imagine a product team. They just launched a cool new feature in their SaaS app. They need to know, like, now are people using it? How?
Right. So picture this. They've set up streaming ingestion using the storage right API. That event data lands in a table that's partitioned by date and clustered by user ID.
Okay, the setup we just discussed.
Yep. Now, they have dashboards built on this data. Maybe they're even using materialized views to pre-calculate some key metrics, and BI Engine to cache data in memory for super fast dashboard tools.
So what does that mean for the team?
It means their dashboards are updating in near real time. They can see almost instantly who's clicking the new feature, where they're coming from, maybe where they drop off.
Wow, okay. So if they see, low adoption, or maybe users getting stuck somewhere.
They can react super quickly, maybe tweak the UI, push a small update, and then immediately see the impact of that change on the same dashboard, all potentially within a single day or development sprint.
That's a tight feedback loop.
Yeah.
And you can scale that kind of analysis.
Absolutely. That same architecture supports analyzing millions, even billions of events, running complex cohort analyses to see how different user groups behave over time, maybe even powering customer-facing analytics within your SaaS product. It becomes the backbone for data-informed decisions every day.
So it really comes back to that core idea. BigQuery gives you the raw power, the scale. But unlocking its speed and cost effectiveness for SaaS, that requires a thought-out architecture. Ingestion, partitioning, clustering, modeling, cost control, they all work together.
Couldn't have said it better. The engine's powerful, but you need the right blueprints to build something fast and efficient with it.
So as we wrap up, maybe a final thought for everyone listening. Look at your own analytics pipeline right now. Where are those bottlenecks? Where does it feel slow or expensive? Based on what we dove into today, what's maybe one architectural change, better ingestion, adding partitioning, getting a handle on costs that could give you the biggest lift in getting faster, more useful insights? Something to think about. Thanks for joining us for this deep dive.